Hi Arjun, thanks for joining us today. Could you briefly introduce yourself?
Sure. I'm a front-end developer specializing in JavaScript, React, TypeScript, performance optimization, and modern front-end testing, with experience building scalable enterprise applications.
Great. Let's start with JavaScript. What exactly happens when you execute a JavaScript program in the browser?
JavaScript execution starts with the runtime setting up the execution environment. Synchronous code runs on the call stack, while asynchronous operations such as timers, network requests, and events are handled by the browser APIs. Once they're ready, their callbacks are placed into the appropriate queues, and the event loop coordinates when they can execute.
You mentioned the event loop. Can you explain the difference between microtasks and macrotasks?
Sure. Promise callbacks, queue microtask, and similar operations go into the microtask queue. Timers like setTimeout are generally scheduled as tasks or macrotasks. After the current synchronous code finishes, JavaScript processes the microtask queue before moving on to the next task.
Okay, let's make it practical. What will this print?
It prints A, then D, then C, and finally B.
Why?
A and D are synchronous. The promise callback is a microtask, so it runs before the timer callback, which is a task.
Good. Now let's talk about closures. What is a closure, and where have you used one in a real application?
A closure happens when a function retains access to variables from its lexical scope even after the outer function has finished executing. In real applications, closures are commonly involved in event handlers, callbacks, debouncing, custom hooks, and maintaining private state.
Can closures cause memory problems?
They can contribute to memory retention if a long-lived reference keeps a closure alive unnecessarily. For example, an event listener or subscription that isn't cleaned up can retain references to objects that are no longer needed.
Good. Let's move to asynchronous JavaScript. Suppose you have 3 independent API calls. Would you execute them one after another?
Not necessarily. If they're independent, I'd normally execute them concurrently using promise.all or another appropriate promise combinator.
When would you use promise.all settled instead?
When I want every operation to complete even if some of them fail. For example, if a dashboard loads 5 independent widgets, one failed widget shouldn't necessarily prevent the other 4 from displaying.
Let's move to React. What happens when you call a state setter such as setCount?
It schedules a state update. React then renders the relevant component tree, compares the new result with the previous one during reconciliation, and commits the required changes to the DOM.
Does every React render cause a DOM update?
No, a render means React calculated the next UI representation. The reconciliation process determines whether an actual DOM mutation is necessary.
Good distinction. What is React Fiber?
Fiber is React's internal architecture for representing rendering work. It allows React to break work into units, prioritize it, and support capabilities such as concurrent rendering.
Now suppose a parent component renders again. Will all of its children automatically render again?
By default, React may render the child components again as part of rendering the subtree. But whether that results in DOM changes is a separate question. We can also use appropriate component boundaries and memoization where profiling shows it is beneficial.
You mentioned memoization. When would you actually use React.memo?
I'd use it when a component receives the same props frequently and re-rendering it is actually expensive or unnecessary. I wouldn't automatically wrap every component with React.memo.
Why not?
Because memoization has its own comparison overhead and doesn't help if props are changing on every render anyway.
Let's talk about hooks. What's the difference between useState and useRef?
useState stores data that participates in rendering, and updating it causes a re-render. useRef stores a mutable value that persists between renders without causing a re-render when it changes.
Give me a real example where you'd use useRef.
A DOM reference is one example. I could also use it to store a timer ID, a previous value, or some mutable value that doesn't need to trigger rendering.
What about useEffect? When should you use it?
I use useEffect when I need to synchronize React with something outside React, such as subscriptions, browser APIs, timers, or external systems.
What is a common mistake developers make with useEffect?
Using it for derived state. For example, if I can calculate, const full name is equal to $, a first name, a $, last name. During rendering, I don't need an effect just to calculate it.
Good. Another common issue. Why can an effect appear to run twice during development?
React strict mode can intentionally exercise effect setup and cleanup to expose bugs in effect logic. The correct approach is to make the effect properly handle setup and cleanup rather than trying to suppress the behavior.
Since we're hiring for a modern React role, what important features from React 19 have you worked with?
React 19 introduced actions, useActionState, useFormStatus, useOptimistic, the use, API, ref as a prop, and improvements around forms and metadata.
Let's take useOptimistic. Give me a practical example.
Suppose I have a social media application and a user clicks like. Instead of waiting for the API response before updating the UI, I can optimistically show the like immediately. If the request fails, I reconcile the UI with the actual server state.
What about use?
Use allows React to read supported resources such as promises during rendering. When the promise is pending, it can work with suspense to coordinate the loading state.
Have you looked at React 19.2?
Yes. React 19.2 introduced features including useEffectEvent, activity, cacheSignal, performance tracks, and partial pre-rendering.
What problem does useEffectEvent solve?
It allows event-like logic call from an effect to access the latest props or state without making that logic itself reactive in the same way as the effect. It's useful when the effect's lifecycle and the event logic have different dependency requirements.
Would you use useEffectEvent just to remove something from the dependency array?
No. I'd use it when the logic genuinely represents an effect event. It shouldn't be used as a workaround for dependency management.
Let's say a production React application suddenly becomes slow. What's the first thing you do?
I measure before optimizing. I'd reproduce the issue and use React DevTools Profiler and the Browser Performance panel to identify whether the bottleneck is rendering, JavaScript execution, network, or something else.
Suppose you discover that one component is rendering thousands of times. What would you investigate?
I'd investigate what is causing those renders. State updates, parent renders, context changes changing, object references changing, callback reference, expensive calculations. Then I'd optimize the actual cause.
How would you handle a React table with 100,000 rows?
I wouldn't render all 100,000 DAM rows. I'd use virtualization so only the visible rows are rendered. Depending on the use case, I'd also use server-side pagination, filtering, and sorting.
Suppose the table is still slow after virtualization.
Then I'd profile the individual rows and cells. I'd look for expensive formatting, unnecessary calculations, unstable props, excessive DAM complexity, and expensive event handlers.
Good. Now imagine your JavaScript bundle is 6 megabytes. What would you do?
I'd analyze the bundle first rather than randomly removing dependencies. I'd look for large libraries, duplicate dependencies, unused code, missing code splitting, and routes that are loading functionality they don't immediately need.
What techniques would you consider?
Route-level code splitting, dynamic imports, lazy loading, dependency optimization, tree shaking, and moving functionality to the server where appropriate.
Let's move to TypeScript. What's the difference between any and unknown?
Any effectively disables type checking for that value. Unknown is safer because I have to narrow or validate the value before using it.
Which one would you prefer for an API response before validation?
Unknown, followed by runtime validation.
What is the difference between interface and type?
Both can model object structures. Interfaces are useful for extendable object contracts, while type aliases are more flexible for unions, intersections, tuples, and other type compositions.
Can TypeScript guarantee that API data is valid at runtime?
No. TypeScript provides compile time checking. Runtime data still needs validation if we don't fully trust its source.
Let's talk testing. How would you test a login flow using Cypress?
I'd test the important user journey. Visit login. Enter credentials. Submit. Wait for the relevant API. Verify navigation. Verify authenticated UI. I'd use table selectors rather than relying on CSS classes.
Why shouldn't we use cy.wait 5000?
It's an arbitrary timing dependency and makes tests slower and flaky. I'd wait for meaningful application behavior, such as an intercepted API request or a visible UI state.
How would you test an API failure?
I'd use cy.intercept to mock the failure and then verify that the correct error state appears.
What's the difference between Cypress component testing and E2E testing?
Component testing focuses on an individual component in a real browser environment, while E2E testing validates a complete user journey across the application.
Now I'm going to give you a few real-world situations. Don't give me definitions. Tell me what you would actually do.
Sure.
A search box is calling the backend on every keystroke and the API team says you're generating too much traffic. What do?
I debounce the search input, cancel stale requests where possible, and make sure an older response can't overwrite a newer search result.
What if the user types React, then immediately types React 19, but the first request finishes last?
Use request cancellation or a request identifier so only the latest request can update the UI.
A page has 10 API calls and the page takes 8 seconds to load. What would you investigate?
First, I'd check whether they're sequential or concurrent. If they're independent, I'd parallelize them where appropriate. I'd also check API latency, network waterfalls, payload sizes, caching, and whether every API is actually required before rendering the initial screen.
Would you put all 10 requests into one useEffect?
Not necessarily. I design the data dependencies based on the UI. Some data might be required immediately, while other data could load progressively.
Users complain that the application becomes slower after keeping it open all day. What would you check?
I'd investigate memory usage and look for leaks from event listeners, timers, subscriptions, WebSockets, detached DOM nodes, caches, or other resources that aren't being released.
You inherit a React application with Redux everywhere. Every small UI state is in Redux. Would you migrate everything to useState?
No. I'd first understand why Redux is being used and distinguish server state, global client state, and local UI state. I'd gradually move state to the appropriate ownership level rather than doing a wholesale migration just because another library is smaller.
So would you remove Redux?
Only if there's a clear technical and business benefit. The goal is better architecture, not replacing a library for its own sake.
A developer has added useMemo, useCallback, and React.memo everywhere because the application is slow. Is that good optimization?
Not necessarily. I'd profile first. Memoization can help with specific expensive computations or unstable references, but excessive memoization adds complexity and doesn't guarantee better performance.
Production is showing a JavaScript error that nobody can reproduce locally. What's your approach?
Decollect the production stack trace, browser and environment information, inspect the relevant network requests, check source maps and application logs, and try to reproduce using the same production build and conditions. I wouldn't immediately change code without understanding the failure.
Last technical question. You're asked to build a large React application from scratch in 2026. What would your architecture look like?
I'd separate UI state, server state, domain logic, API layer, reusable components, feature modules, testing. I'd use TypeScript throughout, establish component and feature conventions, implement appropriate error and loading boundaries, and define a testing strategy from the beginning. For performance, I'd consider code splitting, virtualization for large datasets, caching, optimized API access and monitoring. For testing, I'd use focused unit component tests where appropriate and Cypress E2E tests for critical user journeys. Most importantly, I'd keep the architecture simple enough for the team to maintain.
That's a good answer. Thank you, Arjun. That concludes the technical discussion.
Thank you, Aarti. It was great speaking with you.
And that brings us to the end of this 15-minute front-end React mock interview. But in an actual interview, this discussion can easily go beyond 30 minutes with deeper follow-up questions, real-world scenarios, and technical discussions. Remember, answer point to point, give real examples, stay calm, and never be afraid to say you don't know. If you found this interview useful, don't forget to like the video and subscribe to the channel. For more React, Angular, Node.js, JavaScript, TypeScript, performance, testing, and front-end interview preparation. See you in the next interview.